Welcome to the chapter on batters, doughs, and quick breads. First, we will look at flours. Wheat is the principal grain used in the United States for flour. Flour provides structure, texture, and flavor to baked products. The starch in flour strengthens the baked item through gelatinization and contributes to the crumb. Crumb is the texture of a baked product's interior. It's partially created during baking and by the number and size of air cells produced. The starch is also gelatinized and protein is coagulated. The starch in flour can also be broken down into dextrin, malt, and glucose, adding sweetness, darker color to the crust, and improved fermentation. Now let's look at the process of how flour is actually made. So the process of milling is when the grain kernel has been freed from the bran and germ and the endosperm is ground into a fine powder, which is called flour. There are 5 steps to milling. The first step is breaking. Breaking is when the bran and germ are removed and the endosperm is left. Purifying is when they blow air currents through the endosperm to finish removing any leftover bran that is still in the product. In the reducing step, they grind this into flour. In the sifting step, they divide the milled flour into different streams of flour, and these are based on particle size. And then finally, they classify the flour as either a fine or coarse flour. Now, there are different types or grades of flour. There's what we call straight grade, which is the flour containing all of the different types of streams that are produced during the milling. And there's the patent flour, which contains the finest streams and the most refined and highest quality. The types of wheat flour, most of them you're going to be very familiar with. First, there's whole wheat, which is ground from cleaned wheat grains, which include the bran, the germ, and the endosperm. One thing about wheat flour is you do have to typically refrigerate it because it contains the germ, which has got a fat component. It is more prone to rancidity. And when you form breads or other baked goods with whole wheat flour, you're going to have a much denser dough and usually a much denser crumb. With bread flour, this is a high gluten, hard wheat flour. It contains more protein, usually about 11%. It's more elastic and it creates a higher volume bread. So your bread is going to rise higher. It's going to have a fine texture, probably finer than whole wheat. Then you have cake flour. Cake flour is a soft wheat, produces a very fine textured product, has less protein, and it's more tender. And it's used for things like cakes, for example, angel food cake. Then you have all-purpose flour, which is the one we're probably most familiar with, and this is a blend of hard and soft wheat. And so really it's the best of both worlds. It has a little bit less protein than bread flour, but it has a little bit more than the cake flour, and it can be used for multiple different preparations, anything from breads and quick breads to cookies to the very nicest of cakes. And then finally, durum flour, which is called semolina, has the highest protein content and it's really suitable for pasta making. Let's look at the process of gluten formation and how and what is gluten. So gluten is a 3D network of hydrated proteins with starch granules that are embedded. It's an elastic protein network, and there are really 2 proteins that form gluten. One of them is called glutenin, which is a long chain protein with lots of elasticity, and the other one is called gliadin, which provides more fluidity and stickiness. And the gluten is really developed by kneading and also by stirring. The step to gluten formation include, first of all, hydrating the flour mixture, which, if you add the water, you're going to develop the proteins and eventually develop the gluten. So water is key to developing gluten in baked goods. And also the other step is kneading the dough, which increases gluten development. So there are also ways which you can inhibit or prevent gluten formation, and one of them is by utilizing a lot of fat in the recipe. So fat is named by another name called shortening, and the reason that it's named shortening is because it shortens gluten strands and therefore will not give you that elasticity and chewiness that you would get from developing a lot of gluten. You also would have sugar interfering with the gluten formation, and what happens with sugar is, you remember, it binds with water or it ties up water such as that is unavailable for gluten formation. And then finally, using something like whole wheat flour, for example, the bran in the whole wheat flour is very coarse and it will cut gluten strands similar to fat. Now, what happens when you knead the dough? Kneading the dough actually helps you in gluten formation because it compresses and stretches the dough to increase the development of gluten. It also distributes the yeast to all sources of food. Remember, there are carbohydrates all throughout the dough because it's made from flour. So if you distribute the yeast to all areas of the dough, it's going to have more food to eat and it's going to develop more carbon dioxide. It also redistributes air bubbles throughout the product. It warms the dough, increasing fermentation and the production of carbon dioxide. And finally, it realigns the protein molecules so they run in the same direction, forming cross links, which are important for bread rising. Next, we're going to look at these leavening agents, which are the agents that help us to aerate a product and therefore create volume. And there are three types of leavening agents. The first is physical, and so with air and with steam, we can bring about leavening of a baked good. Then we have biological leaveners, such as yeast and bacteria, and finally we have chemical leaveners like baking soda and baking powder. So first, let's take a look at the physical agents. The first one would be air. So air expands with heat. It is usually insufficient to completely leaven a baked good, so it's usually used in addition to other agents to leaven a baked good. So air is incorporated in several different ways. One of the ways that we can do it is by sifting the dry ingredients together. As you sift your flour, your baking soda, your baking powder, your salt, and things like that, you actually incorporate a little bit of air each time you do that. You also can do it by creaming shortening and sugar together. And as we've seen by, when we looked at the cake method or the traditional method or the conventional method of making cakes, we saw that the reason that we creamed the shortening and sugar together was to incorporate air bubbles. And then finally, beating egg whites and incorporating a lot of air into that egg white product will give you a lot of leavening power. So air alone, the only product that you can really sort of do that with is angel food cake. And we're going to make angel food cake in the lab, and you'll see that air is the only source of leavening for that product. And it consists of creating many, many, many small air cells through the whipping of egg whites. But then you also have air plus other leavening agents so that the gases seep into the air cells and expand them. And this is the way that we sort of leaven some cakes and cookies and yeast breads. Steam is another method that we can use to leaven baked goods because the volume of water increases as much as or more than 1,600 times as water vaporizes. It takes up a lot more room, so it leavens products. Okay, But water alone usually cannot leaven. You combine it with other things like air and or carbon dioxide. You also need high baking temperatures because what's going to happen is you're going to take that water and you're going to get it quickly to the boiling point so you can create steam inside of the baked good. So what a couple of the examples of using steam to leaven a baked good are popovers. So popovers are mostly steam leavened and they're done by beating the batter to add air cells. And the recipe also has a high proportion of liquid to flour. So there's a lot of liquid in there to evaporate to cause all this steam to leaven the product. And so it's also cooked very quickly at a fairly high temperature, 450 degrees for the first 15 minutes, then you lower it down so that you don't burn the top. And finally, another example of how steam is used is with pie crust. So basically, when you cook pie crust, you cook it again at a high temperature and you have fat embedded inside of the pie crust. So as the fat melts, steam seeps into those spaces from the fluid that's in your pie crust and it causes those little spaces to become bigger, and that causes your pie crust to be airy and got some nice volume to it. So other sources of leavening would be chemical leaveners, and one of them would be baking soda. So baking soda yields carbon dioxide in the presence of moisture and an acid. And you would use about 1/4 teaspoon of baking soda for each cup of flour in a baked good. It's not usually used by itself because you tend to require a whole lot of it to cause the leavening to occur. And sometimes if you use too much baking soda, you can end up with either a bitter or a very salty taste to your product, which is not really what you're looking for. You also need to add an acid and to your baked good in order for the baking soda to react. Examples of acids would be cream of tartar, lemon can be used, vinegar, molasses, brown sugar, cocoa, or chocolate are all examples of acids that can be used to react with the baking soda and create carbon dioxide. If you're going to use cream of tartar, you need about 3/4 teaspoon for each 1/4 teaspoon of baking soda that's used. One thing about using baking soda is that usually you have to, once your dough or your batter, and many times with baking soda it's more of a batter situation, once it's mixed, it needs to be put into the oven very, very quickly because it will start to leaven on your countertop. And then because you're not applying heat and you're not getting the rest of the reaction to occur, it will leaven a little bit and then it will flop back down and will not leaven back up. So it's like you're getting out of the gate, but you're not finishing the race. And so that's not a really good way to do this. So basically, once you've done mixing all of your ingredients together, you want to immediately put it in the oven and have your oven ready at the right temperature. The other chemical leavener is baking powder. So baking powder is actually got baking soda in it, and so what it does is it combines baking soda and an acid, and these are separated by an inert filler. In other words, a filler that doesn't react with either product. And so when you incorporate that into a mixture and you all of a sudden add liquid, this starts to make carbon dioxide, basically. So you need the correct amount of acid to react with the sodium bicarbonate, which is the baking soda, and release carbon dioxide. You also do have available for your use low sodium baking powder. This is made with potassium bicarbonate, and the thing is, yes, it's lower sodium, but the potassium gives it sort of a bitter taste, so you want to be careful how much of that you're using in a recipe. You have a couple of different types of baking powders. You have fast or single acting baking powder, and that's used mostly by commercial bakers. And you want to handle this product quickly, again, or you're going to start losing carbon dioxide. In other words, it's going to deflate on you. You also have double acting baking powder. So it first acts when you, like I said before, add the liquid, and then secondly, it reacts with heat. Okay, and with that one, you're going to use 1 to 1.5 teaspoons per cup of flour. The other product that we use to leaven is yeast. So yeast leavens by fermentation with carbon dioxide, producing carbon dioxide gas. You want to be careful with your yeast because it is alive and it can be reduced. The shelf life of it, or the effectiveness of your yeast, can be reduced by exposing it to air or moisture and warm temperatures. The forms of yeast are defined by their activity. We have several different types of yeast. We have what's called active baker's yeast. We also have what's called brewer's yeast, and finally, yeast used for making alcohol. And so the inactive dried brewer's yeast is the yeast that's primarily grown for nutritional value and flavor. What we're going to use is called active yeast or active baker's yeast. This is widely available. And you do have to look at the temperature of your product that you're putting the yeast in, because if it's too cold, it's not going to react, and if it's overly hot, it's actually going to kill the yeast. So at a temperature of 68 to 81 degrees Fahrenheit, the yeast multiplies best. And first, when you're going to actually start out with your yeast, you're going to start it out by putting it in water to moisturize it and activate it. And so your water ideally is warm to 115 degrees Fahrenheit for rehydration and activation of the yeast. Once it's activated, don't really lower your temperature below about 100 degrees Fahrenheit because it can result in sticky dough and lower dough activity. At the same time, temperatures that are higher than 130 to 140 degrees kill yeast. And so don't try putting that in the oven and putting your oven at the lowest temperature, which is about 180 degrees, because that will effectively kill your yeast. And you're going to use 1 packet of yeast, which is standard 2 1/4 teaspoons, for every 4 to 6 cups of flour in your recipe. So like I said, there is quick rising or fast acting yeast. This yeast is primarily used commercially. It reproduces more quickly, and the bread rises twice as fast as with active yeast. So there's about a 50% reduction in rising time. So for commercial manufacturers, it's really important to decrease that rising time so that they can produce more product. There's no need also for a second rising. However, there's less flavor that's developed. You're not going to get that yeasty flavor that would come out of a homemade bread, for example. It is also sensitive to temperature and moisture changes. And you need a temperature of about 125 to 130 degrees to activate this type of yeast. The other type of biological leavener is bacteria. So bacteria generate carbon dioxide to produce sourdough bread using a starter. Okay, so there are 2 fermentations that occur when you're making sourdough bread. The first is from bacteria, and the second is from yeast, because you also use yeast to make this bread. It produces a very desirable sour flavor, and your starter is really something that's kept alive, and it's fed additional flour to keep it alive and active. So let's look at the different ingredients that we add to our batters and doughs to see what purposes or what role they play in your baked goods. So with fat like Crisco, for example, its purpose in a baked good is to shorten the gluten strand. It also helps to increase volume. It improves the strength of your crumb. Your crumb is flakier and there's less collapse during handling. It also can provide color and flavor and a very smooth mouthfeel. It also delays staling of baked goods by interfering with the recrystallization of starch molecules. Remember when we talked about syneresis or recrystallization of starch molecules with the amylopectin. Types of fats that are used in baked goods include shortening. Shortening is a widely useful product in baked goods. It has um, lots of temperature ranges that you can use this product with. It contains its own emulsifiers so that it helps you to make sure this mixture of an oily substance with a watery substance comes together, and it's also less expensive than many other types of fats. Emulsifiers distribute fat more evenly in your baked good. Cakes that are made with hydrogenated vegetable shortening, for example, or good old fashioned Crisco shortening, tend to have a higher volume, a finer, more even grain, but they tend to lack the flavor of butter. They have more of a bland flavor, I should say. Oils, on the other hand, will coat flour. They'll prevent adequate gluten development. They're not usually used for making things like bread, but can be used for cakes and quick breads for their tenderizing properties. Now, if you use too much fat in a recipe, you're going to have a weakened structure and you're going to have a decreased volume of finished product because you're going to have shortened the gluten strands too much. If you don't use enough fat, you're going to have a tough crumb and it's not going to be particularly moist or tender. Salt does quite a few things in producing baked good. It obviously, for one of the most important reasons, is that it provides flavor because baked goods without salt tend to be very flat. They don't have much flavor to them. It also helps you with producing a firmer dough. It also helps with volume, texture, even cell structure. It prolongs shelf life, delaying staling, and it controls for yeast growth. And without salt, the fermentation would be too rapid, and you would also not have time to develop gluten enough. So your bread would rise too quickly, in other words. So if you don't have enough salt in your recipe, your fermentation is going to be too rapid, and you're going to have a sticky dough and difficult to handle dough. If it's too much salt in the recipe, it's going to inhibit the yeast activity, decreased production of carbon dioxide, and decreased volume of the loaf, and a very salty taste. With liquids in your baked good, whether they be milk or water, they hydrate the starch, so you can have gelatinization of your starch with heating, and they also develop gluten. They also help to dissolve sugars, salts, and baking powder. They're required for starch gelatinization and formation of the structure. They're required to activate the yeast. They provide steam for leavening. They allow baking soda or powder to react and produce carbon dioxide. And typically in a baked good, milk is better than water, and typical bread recipes, for example, have you adding milk instead of water, and so many cake recipes for the same thing. Gives you flavor, gives you a velvety texture, a creamier crumb, and a brown crust because of the Maillard reaction, and the products tend to retain their shape due to the fact that the milk has fat and also has functions as an emulsifier. Now, sugar. One of the obvious reasons behind adding sugar to the dough is that it provides, again, flavor. It sweetens the product. It also helps you to incorporate volume or to increase volume by incorporating air during the creaming with fat. It tenderizes or has a tenderizing effect on gluten. It retains moisture by its hygroscopic nature. It contributes to brown coloring by the Maillard reaction. It provides food for the yeast. It delays staling by absorbing moisture again and making the product feel less dry. And it competes with flour for water, delaying gelatinization, giving gluten more time to stretch and create volume. Now, with sugar, if you have too much sugar, your product may fall. You may have a lower volume, a coarse grain, a gummy texture, and an excessively brown crust. If you have too little sugar, you may have dryness, reduced browning, lower volume, and a less tender product. So first we'll look at quick breads, and then in the following chapter we're going to look at yeast breads. So quick breads include a variety of products that can be prepared without the rising or proofing time required by yeast breads. Quick bread utilize the leavening powers of chemical leaveners, which act immediately or quickly. It's not necessary to cook them for an extended period of time because leavening has already taken place before the items are cooked. The other thing you want to look at is to make sure you understand the difference between a batter and a dough. A batter has got enough liquid to be beaten or stirred. A muffin batter, for example, the ratio of liquid to flour is 1 part uh, flour to 2 parts liquid. With a dough, it's less liquid in relation to flour, so it can be handled and kneaded. So a stiff dough, the ratio of liquid to flour is 1 part liquid to 6 parts flour. So methods of mixing batters and dough, again, we're going to look at these, but we've looked at these before. The muffin method, where the dry ingredients are sifted together in a bowl, the egg, liquid, and fat are combined, and the liquid is then blended with the dry ingredients. The biscuit method is where the dry ingredients are sifted together. The fat is cut in or blended with the dry ingredients, which makes it different than the muffin method. And then liquid is then added to the fat and flour mixture, and it results in a much more flaky product. And finally, the conventional method is where fat and sugar are creamed together, eggs are then added, and then the dry and liquid mixture ingredients are alternately blended in with the fat, sugar, and egg mixture. So quick bread pour batters include pancake batters, crepe batters, waffles, and popovers. And then drop batters include things like muffins, cornbreads, hush puppies, tea cakes or tea breads, coffee cakes, and dumplings. And then quick bread doughs include things like biscuits, scones, and tortillas. And that concludes our presentation.